Okay, let's look at example number 2 for tonight's homework. We have to solve some triangles, which means find missing sides. In this case, there's 2 ways to do this. We can use SOHCAHTOA, or we can use some shortcuts. I think it's important that we know how to use SOHCAHTOA, and we'll also discuss the shortcuts. All right, so in this case, we have a known hypotenuse of h, so we know that h is 7, and we have an angle of 45 degrees. So what we want to do is say, okay, let's say we wanted to find y. It's important to note that for 45 degrees, y is next to 45, or y is the adjacent side. X is across the triangle, right? It's on the other side of the triangle from the angle, so it's the opposite side, which we'll abbreviate OPP. If we know the hypotenuse and we want to find the adjacent, that lets us know that, hey, look, A is for adjacent, H is for hypotenuse. So for the first one, we're going to be using cosine. So let's go ahead and write that out. The cosine of theta is equal to the adjacent over the hypotenuse. In this case, we know the angle is 45 degrees, so this is cosine 45 degrees is equal to, and then we do not know the adjacent, so we'll call that y. But we do know the hypotenuse is 7, so we'll substitute in 7. At this point, what we want to do is say, hey, look, we're looking for 7, we're looking for y, so let's get rid of divide by 7 by multiplying by 7. And then whatever you do on one side of the equation, you have to do on the other. So y will be whatever 7 times the cosine of 45 degrees is. And that's actually something we can go ahead and type out with a calculator. Remember, when you use a calculator, you always want to make sure you're in degrees, right? If this is 45 degrees, we need to check our mode. So let's actually go over and use the calculator that's on my computer so you can see that happening. Let's open her up. All right, and so we need to check our mode. So let's go to mode. The moment I'm in radians, so let's change that over to degrees. Hit enter. Let's hit clear, and we'll just do 7 cosine 45. And what we get is 4.949 or 4.950 as a total. So that's our y value. Y equals 4.950. We also could use a shortcut. We learned some special properties of 45, 90, 45 triangles that says the relationship between the sides and the hypotenuse means whatever the sides are multiplied by square root of 2. So if you know the hypotenuse, you can divide by square root of 2. So 7 divided by square root of 2. Let's go ahead and check to see if that would have worked. 7 divided by square root 2. Yep, sure enough, we get the exact same answer. I think it's much more important that we remember SOHCAHTOA, because SOHCAHTOA works for any angle. It's more important to know that than it is to know shortcuts for certain angles. So same thing for this problem. There could be a shortcut. Let me go ahead and add the 90-degree angle here. There could be a shortcut for this, and I'll cover that later. But first thing we want to do is make sure we know how to use SOHCAHTOA. So I'm going to erase this space. If you need this, please pause the video. So here, we need to look at where our angle is. Our 60-degree angle is in the bottom right corner. So this is the angle 6. This is a side that's close, so this is adjacent. Q is all the way across the triangle, so this is opposite. And then this longest side is always the hypotenuse. So in this case, we know the adjacent. And let's say we wanted to find the opposite first. We know adjacent and we want to find opposite. That's TOA, because O is opposite, A is adjacent, so that makes TOA a good choice. So the tangent of theta is going to be equal to the opposite over the adjacent. In this particular case, we know that theta is 60 degrees. We do not know what the opposite is. We'll call that Q. But we do know that the adjacent is 6. And this one's going to be the same kind of step. To get rid of divide by 6, we need to multiply by 6. And then whatever we do on one side of the equation, we must do on the other. So we're going to multiply on 6 on the left. And our answer will be whatever 6 times tangent 60 degrees is. And so once again, let's flip back over to our graphing calculator on the other screen. We're still in degrees, but it's always important to double check. So let's go back to mode. Yep, we're in degrees, so we don't need to fix that. And we just need to do 6 tangent 60 degrees. And we get a value of 10.392. So let's go ahead and write that in as our answer. Equals 10.392. And that's our Q value. We could have used a shortcut here, which says that whatever this side is, this side has the property of being double. So, no wait, that's not right. Sorry, whatever this side is, this side has the property of being double. So we can kind of predict that this is going to be 12. Whatever this side is the same amount times the square root of 3. So 6 square root of 3 should be 10.392. Let's just double check that it is. 6 times the square root of 3. Yep, sure enough, we get the exact same value. But it's more important, I think, that you know how to do SOHCAHTOA. So for tonight's homework, I would encourage you to use tangent, cosine, sine, instead of those special triangle properties. Although if you do know the special triangle properties, that's fine too. Okay. So we found the opposite. Now let's go ahead and find the hypotenuse. So if we want hypotenuse and we know adjacent, hype and adjacent, those are found in this word, adjacent and hypotenuse. So it lets us know that the cosine of 60 degrees is equal to adjacent over hypotenuse, so in this case 6 over big S. Now this one's a little bit different because it doesn't say divided by 6, it says divided by S. So we need to get rid of that by multiplying by S on both sides. And so now we have S cosine 60 equals 6. And we're still trying to solve for S. So we want to divide by cosine 60 and divide by cosine 60. And like I said, we should get 12 is our result, because if you have a 30, 60, 90 triangle, the shortcut is the hypotenuse is always double the short side, so double 6. Let's just go ahead and work this out and see if that happens. 6 divided by cosine 60 degrees. Yep, sure enough, we get 12 as a result, which is what we predicted using this shortcut for special triangles. So we have 12 as our answer for this, right? So this was 10 point something, I think 10.9. This was 12. So both of these are just SOHCAHTOA problems. I think we have one more SOHCAHTOA problem. It's on the next slide. It looks like this. Once again, it's good to label our sides. This is 60 degrees, so this is the nearby side. That makes this the adjacent side. This is the longest side, so that makes this the hypotenuse. And then for a 60-degree angle, N is on the other side of the triangle, so this is our opposite side, because it's on the other side of the triangle. Let's go ahead and write out SOHCAHTOA. So we know hypotenuse, so we're going to use this one or this one. And then let's just say we wanted to find opposite first. We wanted to find O first. That lets us know we're going to be using sine first. So sine of 60 degrees equals opposite over hypotenuse. So n over 5. And this is just a one-step equation. We're going to get rid of divide by 5 by multiply by 5. And then whatever we do on one side, we have to do on the other. So 5 sine 60 is going to be our n value. So 5 sine 60. And we get that n is about 4.33. So we get an n value of about 4.33. Now I'm going to go ahead and guess that if this is about 4.33, this is going to be about 2.165. And my guess is, I know that since this is a 60, 30, 90 triangle, no, I'm sorry, I'm not going to guess that. I'm going to guess that this is going to be 2.5. If this is a 60, 30, 90 triangle, the shortest side is always half the length of the hypotenuse, and the hypotenuse is always double the length of the shortest side. So I'm guessing 2.5 is going to be our final result for this. But let's go ahead and work it out the long way and find out. So this time we're going to be using cosine, because we know the hypotenuse, and we want the adjacent. So that makes CAH a good choice. So let's go ahead and write that out. The cosine of 60 degrees is equal to the adjacent, which we do not know, over the hypotenuse, which we do know is 5. And we're just going to solve this equation. Get rid of divide by 5 with multiplication. Got to do it on both sides. And so whatever 5 cosine 60 is going to be our m value. And like I said, I've predicted that's going to be 2.5. Let's just go ahead and double check 5 cosine 60. And sure enough, it's 2.5. And so we're done there. All right. So 2.5 and 4.33, and then 5. So these were all SOHCAHTOA problems. It's important to know SOHCAHTOA. Since they used 45-degree angles, 30-degree angles, and 60-degree angles, there's some shortcuts we can take. But I would much rather us kind of remember SOHCAHTOA because it works for any right triangle. So it's a better formula to memorize because it applies to every right triangle. So it's important to kind of do them the SOHCAHTOA way. We can just use shortcuts to kind of check our work or predict our answers. All right, that's all for number 2.